Hello, guys. In this lecture, I'm going to continue our discussions on polar coordinates and relating accelerations that are found in polar coordinates with forces, right? Let's do a brief recap on here. So we said if you have an object and that object, is going along, any random curve, right? So what we have is, if we locate the radius to this object, and then we can find theta, right? In the gross direction of theta, we have our, um, transverse acceleration, right? And that acceleration is going to be equal to what? R theta double dot plus 2 r prime theta prime. And in the radial direction, we are going to have r double dot minus r theta prime square. All right. So these are always the accelerations that we are going to have. So this is the radial direction, and then this is the transverse direction. Okay. Let us do basically this very first example that we actually have here in our node. So we have when an airplane is executing a loop, right? Uh, this particular loop basically uh, will cause the pilot to basically feel weightless, right? So when the plane is at A, the pilot experiences weightlessness at this point, right? We need to find the velocity of the plane, right? What is the plane velocity at A? Um, so we need to find the velocity at A, right, for the pilot to feel weightless. So how are we going to approach this problem? So we said the first thing that we have to do is we have to do a free body diagram, right? And what I'll do is I'm gonna start here. Okay, so this is our pilot. We're gonna draw two diagrams, right? So this is external forces, and then these are the inertial acceleration. So here we're, this is my F is equal to ma. What are the forces that are applied on the pilot, right? So the pilot is, kind of sitting upside down on the plane, right? He will have a few forces that he's going to be experiencing. One of them is going to be, so the plane is definitely pushing that pilot to the right, to the left, I'm sorry. Well, it could be pushing him or it could be decelerating him. We don't know. So, but we know definitely we are going to have a net force in that direction. And that force, it could be either the seat of the plane is pushing the pilot to the left, or it could be the seat belt is basically holding him back, right? But we know we're going to have a single force P. And we know here we're describing basically the external forces which are applied on the pilot. Well, we know he's going to have a force mg, basically. That is his weight. And the last thing that we do is basically we have n is the reaction from the seat on the pilot. And again, n could be like this or it could be upside down, right? Because if you are sitting on a plane and then you're flying it, the actual belt will go all over you, right? All over basically your shoulders. So this n could actually be reversed for the pilot to be not to be able to kind of, lift up just like the same seat belt that you actually use when you are flying on a plane. Okay, so we know we have two unknowns, right? N and then P. And on this end, basically, what are we going to put? We're going to put our accelerations, right? What are the accelerations that we have here? Well, in the gross direction of theta, I'm going to have my transverse acceleration. And then this guy is going to be equal to M multiplied by R theta double dot plus this Coriolis component, which we all know is 2r prime theta prime. And the other thing that we have is in the opposite direction of r. So now I'm basically using the opposite arrow. So can you guess what that should be? Maybe you can pause the video and then to make sure that you have it. So this is going to be m r theta prime square, right? Because now my r theta prime square is actually pointing downward, and then minus r double dot. Okay. But the question actually is we need to find the velocity of the plane. Well, how do we know the velocity of the plane here? Right? For n to be, so if the pilot is feeling weightlessness, then n is going to be 0. You guys agree? Right? So it's not feeling any pressure with the seat, so n is 0. So if I sum the forces, right, in the vertical direction, I'm going to have n minus mg is going to be equal to, so this arrow is downward, so minus m r theta prime square minus r double dot. So n is 0, right? Well, m is the same here as m, so I always make the silly mistake of using different symbols like capital and then lowercase. But this guy is positive because now we can do that, and then m will actually vanish out. So at weightlessness, and what we have actually is g is going to be equal to r theta prime square minus r double dot. Well, that is still not enough. So we need to find the plane velocity. Well, what is the plane velocity? How can we describe that? Well, we already know from kinematics that the velocity is equal to what? We know the velocity, it has two components. It has a radial component and then it also has a transverse component. In the radial direction, I know it's going to be simply r u naught r, right? Our unit vector in the radial direction, plus r theta prime u theta naught, right? So this is a component of the velocity vector in a transverse direction. And then when they are asking us for the velocity, they are basically asking us for this whole velocity. So we need to find this velocity vector based on this relationship. Well, how can we go from here? Well, we don't know theta prime. We know nothing here, right? But we actually have r. So r is provided to us here as minus 600 cosine to theta. So perhaps we could try and then differentiate that. Well, we know r, right? So r of 0, for example, it's minus 600, etc. We need to differentiate that, right? So what is r prime in this case? R prime is going to be equal. So we're going to differentiate that. So minus 600 derivative of, okay, so derivative of cosine to theta is going to be equal to what? Minus, right? Derivative of cosine is minus, and then 2 theta, so minus 2 theta prime sine to theta, right? So this is the derivative of cosine to theta. Cosine to theta, right, is going to be equal to that. And in general, derivative of, cosine u, if you are differentiating this guy with respect to time, it will be minus u prime, right? Differentiating with respect to time, sine u. Okay, so you never want to forget or disregard this guy here. So derivative of cosine to theta is like we said, so minus 2 theta prime times sine to theta. So what is r prime? R prime is going to be minus times minus is positive. So 1200 theta prime sine to theta. Okay, well, that is not enough because we still need to do another r double dot, right, to get here. So what is r double dot? Differentiate this guy one more time. So it's going to be 1200 theta double dot sine to theta plus 1200. Derivative of sine to theta is going to be equal to theta prime cosine theta, right? So 2, well, theta prime, we already have it. So theta prime square cosine to theta. So my r double dot is going to be equal to 1200 theta double dot sine to theta. 2 times 1200 is going to be 1400 theta prime square cosine to theta. Well, what else do we know about this? So how can I find r double dot? Well, I know r double dot is simply a function of theta and theta double dot. Well, what is theta? I know theta is actually equal to 90 degree in this case, right? So theta is actually equal to pi over 2. If theta is equal to pi over 2, then what is r double dot? So this guy is going to be 0, right? Because sine 2 times pi over 2 is sine 80. And then we know from cosine and sine, we know sine of 180 is basically 0, right? And then cosine of 2 times 90 is minus 1, right? So minus 1400 theta prime square. Okay, so this is my r double dot. Well, what I could do is now I can take this guy, take this equation that I have here. So G is equal to r theta prime square minus r double dot. So it's going to be plus 1400 theta prime square. All right. Well, what is r? Well, I know what r is, right? R is given to me as minus 600 cosine theta. So G is equal to Uh, so we said, oh, okay. Uh, okay, cosine 2 theta, right, is going to be -1. So minus times minus is going to be 600, right? So 600 plus 1400 theta prime square. Okay. So now we can basically find the angular velocity of the plane. So theta prime is going to be equal to square root of g over 600 plus 1400. So now we have our theta prime, right? But we are asked to find the velocity of the plane. Okay, how do I find the velocity of the plane? Well, I know theta prime and I know r. I still need to know r prime. What do you think r prime is? Well, r prime is equal to this guy, and sine of 2 times 90 is equal to 0. So r prime is 0. So what we end up with is, so this guy would be 0, because at theta is equal to 90, r prime is 0. So we only end up with velocity is equal to r theta prime. Well, what is r theta prime? Well, we already know that r is equal to 600, right? Multiplied by theta prime, which we already just solved right here. This guy. So square root of g divided by 600 plus 1400, right? And then this is in the u theta direction. So it all makes sense, right? So this is going to be your velocity. All right. This is going to be your velocity, and it's all clear basically, right? Okay, guys, so make sure you are solving all the problems. It's extremely important if you want to get an A on this course, and just do all the assignments, all right? And then obviously another thing would be, in addition to doing your assignments, you can also go on Google, and then you can look up sample exams or sample dynamic one exams. And like I mentioned last time, is there's a lot of universities that actually offer that, like MIT OpenCourseWare, for example. And then there is so many universities in the US that basically they put their exams online and then their solutions. So nothing really prevents you from sitting there on a weekend, or basically like every day during the week, to basically practice and prepare and prepare and prepare. All right. Okay, so last time we did this problem. I want you guys to do it also on your own without watching my lecture, and then make sure you fully understand it. All right, so we're good. Let us solve here one more problem. Also about a plane. Um, okay, so what we have here is that we have the pilot of the plane executes a vertical loop, right? A vertical loop. So this loop basically is just like what we did before, right? It's a vertical loop. And the path is basically given by this. So we know r is equal to how much? 200, 1 plus cosine theta. So this is my curve. Theta is in radians. If his velocity at A is constant, right? So we know the velocity at A is constant, and then it's given to us by P is equal to 85 meters per second. We need to find the vertical reaction the seat of the plane exerts on the pilot when the plane is at A. He has a mass of m is equal to 80 kilogram. All right, so how do we do this? So we have this curve, we have his velocity, so we have all the information that we need. We need to find his reaction at A. So on the exam, guys, it's of paramount importance that you write in a very nice and clear way, just like the way that I present my information here. This is what I would like to see: nice and clear free body diagrams, forces on the left, accelerations on the right. If you put your acceleration on the same diagram as the forces, I will take point off. All right, make sure you don't put the acceleration on the same image. All right, it has to go on a separate image, and you have to also indicate the direction in which you are summing the forces. If you forget this plus and then this arrow, I will also take off points. I'll take a lot of points off, actually. Maybe half the problem will actually be lost if you don't do those. It's very important. All right, and I want to see really nice. So r prime, are the nice and clear sequence of how your solution is propagating. It's very important if you want to get a good grade here. All right. Okay, let's do this problem. So we're trying to find the normal reaction on the pilot. So what do we do here? We're going to do a free body diagram on the pilot, right? So we are looking at the external forces that are being applied on the pilot. Again, okay, so what are the forces on the pilot? We have his weight, right? So no matter what he does, he's going to have a weight, mg, right? And then what else? We have a normal reaction. So like I said, this could be down or this could be up, depending on what is happening with the dynamics. We don't know. And from, we also have another force, and I'm going to call this force F. Okay, again, here we're assuming this, and then after we solve for it, if F is positive, it means that this direction that I assumed is correct, right? Likewise for N. And if the last value that after I plug this F and then it is negative, it means that it is in the opposite direction of what I initially assumed. Now looking at the accelerations, so here we're gonna put the transverse acceleration, and then that has to be in the gross, in the increasing theta direction, right, or in the gross of theta direction. And then here we have our m, and don't forget to put the mass in front of the accelerations, right? You never want to put the accelerations alone, because Newton told you F is not equal to a, he told you F is equal to ma. So m times a, transverse acceleration is r theta double dot plus my Coriolis component to r prime theta prime. Now, I still have the radial acceleration, and I have to look at the r. So r is basically pointing downward, right? This is how it's being measured. So if I actually use the upward direction, I'm going to end up with m multiplied by what? The centrifugal now, right? R theta prime squared. And it is positive because I already assumed this guy is pointing toward the center of the circle, minus r double dot. So now we're good, right? What do we need to do? We need to find the normal, right? How do I find the normal? So we'll just simply sum the forces. So summing the forces in a vertical direction, I'm gonna end up with n minus mg is gonna be equal to what? M r theta prime square minus r dot. Okay. So my n is gonna be equal to what? The mass of the pilot and g plus r theta prime square. Notice here, if you are executing the loop, you're not only carrying your weight, but now you're adding this centrifugal component of the acceleration, right? Minus r double dot. Okay, so we need to know theta prime, and then we need to know r double dot. So how do we do this? So probably the easiest way is to take this r and then differentiate it and then see what happens, right? Well, we know r is equal to 200, 1 plus cosine theta. So I need to find r prime. So r prime is going to be equal to, so this is u times v, so u prime times u prime, or I can just keep that as a constant. So 200, it will cancel out. So 200 cosine theta. So it will be minus 200 theta prime sine theta, right? Differentiating this guy, 200 cosine theta will be minus 200 theta prime sine theta. Now let's look into r double dot. What would r double dot be like? So minus 200, so the derivative of the first variable plus the derivative of the second variable, which is theta prime cosine theta. So it would be minus 200 theta prime and then theta prime. So it will be theta prime squared multiplied by cosine theta. Okay. So we need to know these guys. Well, what is theta prime? Do we know theta prime? We don't know theta prime. They actually just gave us the velocity, right? Well, we know theta is going to be equal to 0, right? So these are evaluated theta is equal to 0. So if sine 0 is what? Sine 0 is 0, right? And cosine 0 is 1. So r double dot is actually equal to how much? Minus 200 theta prime square, right? And how about r prime? R prime is actually 0. How about r? R is going to be equal to 200, right? 1 plus cosine 0, 1 plus cosine 0, which is times 2, which is equal to 400. Okay. So we're good. So the only remaining thing is if you need to find theta prime. If you find theta prime, we're good. We have this, and then r double dot is equal to that. So we need to find theta. How can we find theta prime? Maybe you can pause the video now and then think about it for a minute. until you figure it out. And then once you figure it out, then you can resume the video that you are watching now. Okay, so now solution of theta prime is they actually gave you the velocity of the pilot, right? And then they told you that it's horizontal. So what do we know here? We know that VP is equal to how much? 85, right? 85, and it is in this direction, right? It's in the u theta direction, right? But we know that VP is equal to what? R prime, right? R prime UR plus R theta prime U theta. We already know this. So this guy must be 0, right? Well, wait a second. If his speed at is constant, okay, so they don't tell us that it's actually u theta. They are simply telling us that the magnitude of the velocity is equal to theta, 85. Okay, okay. So here they is constant. They are not telling us that the VP is actually in the I direction or in the u theta direction. Well, but we do know that VP is equal to R prime UR plus R theta prime theta, right? But what is R prime? Well, I know R prime is equal to this. What is theta? Theta is 0, right? So if theta is 0, then R prime must be 0. We can basically prove it. We can prove R prime is 0 because if you are following this curve, right, this R prime must be 0. So at when angle is 0, the radius could not be increasing because of this sine theta that we have here, and sine 0 is 0. So basically we know VP for sure is equal to R theta prime. So now we know for sure 85 is equal to R theta prime, right? So we can find theta prime, and theta prime is equal to 85 over the radius, and then which is equal to 400. So this guy is in radian per second. So now you have your theta prime. So now what is your n? Your n is going to be equal to what? M G plus R is equal to 400 multiplied by this guy, 85 over 400 squared minus R double dot. What is R double dot? So plus 200 times theta prime square, right? Times 85 over 400 square. Okay, so this is the value for n. Okay, guys, so we know G is 9.8, and then we have supposedly the guy is flying close to the Earth's surface, and the weight of that person is, I believe, 80 kg. Okay, guys, so that is it regarding this problem. Let's see if we can solve one more problem here in this chapter, and this is all included for the final exam. What I'll do is let us actually solve this very last problem. And in this problem, what we have is we have this particle that has a weight of 0.5 kilogram, and then it's confined to move along the smooth horizontal slot. Determine the force of the rod on a particle and the normal force of the slot on the particle. 1 theta is equal to 30. So we need to find the interaction forces between the ball and the rod, right? And then they are giving us the angular velocity of the rod, right? So we need to find the force of the rod and the particle. So there is a force between the rod and the particle. So let's actually look at that, right? Okay, so this is my particle, right? And this is the rod that we have. Okay. And we know that this angle right here is basically theta. Okay, and we know this guy is going to be constrained along this guy, right? So here we have the forces, and then here we have the acceleration. So here, and then here we have inertial accelerations. Okay, what are the forces that you think are between this guy and that guy? We said the forces will always be perpendicular to the tangent, right? All interaction forces will be perpendicular to the tangent. So what are the forces that are applied on this guy? We have normal force perpendicular to the tangent, and then this force here is going to be perpendicular to the tangent, right? So let's call it as force F. Does that make sense? And then what else do we have on this guy? We have the weight, mg. Okay. Now, how about the accelerations that are applied on this guy? You can think about it for a minute. Well, we have the radius r, right? So I'm going to draw the same guy. This is my angle theta. Okay, so we have two accelerations, right? In the gross direction of theta, what do I have? Right? We have this guy, right? Okay, let me just put it here. So this guy is going to be equal to what? M r theta double dot plus 2 r prime theta prime. And then in the radial direction, I have m r double dot minus r theta prime square. Notice sometimes I would write it r theta prime square minus r double dot, and then sometimes the opposite way, depending on how r. Right here, I'm assuming my outward direction to be positive, so that has to be r double dot is positive, and then this is in the opposite direction as r theta prime square. Okay, so how do we need to find the force on the rod, right? So how do we do that? Well, if this angle is, well, we need to know the horizontal angle of the force, right? And I believe if this angle is theta, this angle right here must be theta, right? If this guy is 0, this guy would be 0, right? This guy would be, so instead of being like that, it would be like this, right? And then if this guy is 0, then force will be horizontal. So we know this guy has to be theta, okay? Well, okay, so how about here? If this angle is theta, this angle has to be theta. And then as this guy is theta, then we know this guy has to be theta. You just need one angle for each vector with respect to either the vertical or the horizontal, right? You just need one angle because you could either take the sine or the cosine. So instead of this angle, I could look at this angle, right? And then that's it. I wouldn't need to put the other angle. How do you know the force? So just sum the forces, right? Sum the forces in the horizontal direction. And if you do so, it's going to be F times cosine theta is going to be equal to what over here? Well, this is like vertical, right? And yep, F cosine theta is going to be equal to how much? To this guy, right? M r double dot minus r theta prime squared plus M. So this is nothing here. M r double dot plus 2 r prime theta prime cosine theta. Okay, so this is how we can find the force F, and then how can I find the normal force? And we need to do the same thing and then sum it in the vertical direction. I'm gonna end up with N minus mg minus F sine theta is gonna be equal to my vertical, so I have to use a vertical direction on this end. It will be M r double dot minus r theta prime square cosine theta minus M r theta double dot plus 2 r prime theta prime, and then this whole thing is basically multiplied by sine theta. So we can find F first. Once we find F, we can find N. How do I find? So I need to know these guys, right? So they gave us, well, theta has to be equal to 30 degrees pi over 6. And then we know theta prime is equal to 2 radian per second, right? Move along okay. Okay, so it's rotating with a constant angular velocity. So we know theta double dot is equal to 0, okay? We need to know r double dot. How do I know r double dot? All right, well, how do I know even r? We don't know the value for r yet, right? Well, we do know that this guy is 0.5, right? And we know r cosine theta has to be equal to how much? To be equal to 0.5, right? So maybe we can use this guy to differentiate. If you differentiate both of these guys with respect to time, you're gonna end up r prime cosine theta, right? Plus, so cosine derivative of cosine theta is minus theta, so minus r theta prime sine theta, right? So this is the derivative of cosine theta only. Is going to be equal derivative of 0.5 is going to be 0, right? So now we have r prime. So r prime is going to be equal to r theta prime sine theta divided by cosine theta, which is equal to r theta prime multiplied by tangent theta. Well, there you have it, right? Okay, so we have r prime. Now, if you want to find, r prime when theta is equal to 30, what would be r? R is going to be equal to 0.5 over cos cosine 30 multiplied by theta prime, which is equal to 2 multiplied by tangent 30. So if you do this, basically you will get your r prime when theta is equal to 30. Now, if you want to get your r double dot, you just continue to differentiate this guy, and then what would that be equal to? So r double dot is going to be equal to r prime theta prime tangent theta plus r theta double dot tangent theta plus r theta prime. So derivative of tangent theta is equal to what? Is going to be equal to 1 plus tangent square theta multiplied by theta prime. Let me just make sure this is correct. Yep, we're good. Um, okay, so this is your r double dot. So uh, so now what remains is to simply plug that. So r double dot, right? When theta is equal to 30 degrees. Well, we need to know my r prime. R prime is calculated from here. Um, we know theta prime, we know tangent theta, we know the rest of them. Then we can basically find that. I'll let you guys do the calculations over here. So just r prime is given to you here. So just plug it. We know theta prime, we know tangent theta, we know r is given to me like from what relationship from here, right? So r is always equal to what? Is equal to 0.5 over cosine theta, right? So just plug theta to be equal to 30 degrees and we can get that. We know theta double dot is equal to 0. So this guy is 0. And we know this guy, we know r, we know theta prime, we know 1 tangent square theta. So we're good. So after you find r double dot, what do? You calculate your force, right? So the force is going to be equal to this guy, right? Which is all provided to you. This guy is 0, right? Divide that by cosine theta. And then after you find f, basically you find the normal force. All right, guys. So that is it regarding this problem. And that really kind of summarizes what we have been doing for this chapter. I need you guys to verify that you are solving all of the problems on the assignment. Paramount importance. If you want to do well on the exam, you have to solve all the assignments. And I will actually, if you ask previous students who took my course, I will definitely give you something from the assignment. I'll modify maybe the question, but you will see the same images. All right. Okay, guys, any questions? Do not hesitate to email me. You know what I mean? I'm always available since day one. I told you guys I'm always available. I have an open door policy. That is why I don't really have like, scheduled office hours. So anytime you want to ask me questions, just shoot me an email. We'll set up a Zoom call and I will work with you to make you understand anything that you have. All right. Any questions? Like I said, just send me an email and then I'll be very happy to jump on a call with you. All right, guys. Thank you.